For the C++ movie game, one of my major contributions was handling individual game scenes and transitions between them. I created a struct holding relevant information to be passed into every game scene and to be checked. Within the struct, I hold a pause status, an exit ball. These are checked every update within the scene manager and the current and next scenes to swap to. I also have a vector containing every enum value for the game scene's enum. This provides me enum iteration within my scene manager, allowing me to implement a more efficient factory method of instantiating game scenes. A scene manager object instance is instantiated with a pointer to the ASGE renderer and input systems. This is then passed down to scenes and their derived classes to be used. My factory method returns a shared pointer to a scene. Shared pointers were preferred for scenes as the inability to copy unique pointers added far more complexity and overhead over a shared pointer's reference counter. If the return from the scene factory is a null pointer, we throw it away. When not, we add it to our scene's vector. When instantiation of every game scene is complete, the current scene shared pointer is set to the front of the shared pointer scene vector. Within this scene, an init function is called. An init function was preferred over instantiation within a constructor as it grants easier transitions back from states, such as going back to level 1 from level 2, which would reset the scene and all components within it. Ordinarily, a constructor instantiation is preferred. The scene manager ticks virtual methods within a scene class. Derived scenes from this base class provide the functionality and overload these functions. Function overloading, inheritance, and breaking systems into more component-based design was stretched by me at every point during this game project, as reusability and generalization of systems was a large desire. This is seen in my numerous refactors of the game within my commit history, notably with my game component class, which provides little more than a virtual update function and enum type getting and setting. Every object was intended to inherit from this class as a base, which would provide a callable update function within any class. With type setting, objects can be static casted into different types based on a check over their component type enum value. I implemented this within our render scene functions and our update functions, first ticking every object contained in a vector of game components, then static pointer casting them when required to gain additional functionality, such as player checking or UI specific functions. For example, in the render scene function, we static pointer cast a component within the game components vector into a sprite if they pass a check. We then call the render sprite function. We then assess again if the component was a player type, in which case we cast that sprite into a new shared pointer called player, which then gives us access to the player's bullet vectors. We then loop through them and render them. Due to this being a shared pointer, these are then auto-cleared when they fall out of scope, just like with a unique pointer. This is similarly done in our update functions, where we loop through the game components vector, we tick the update function, and due to it being virtual, it will tick their relevant one. We then get their type and then assess from there any additional methods we might require. For instance, there's a update players function that's specific to the game scenes, where we pass in the delta time and the player, where then we can do appropriate things with a copy of them. This is then auto-cleared when it falls out of scope. Static casting was preferred over dynamic, as exception handling was not seen as required when component type checking was sufficient enough. This decision reduces additional checks every update to give exceptions in cases of failure through dynamic casting.